In this tutorial, I want to go over the relationship between arrays and pointers and pointer arithmetic. So what is the relationship between an array and a pointer? The name of an array is a pointer constant. Constant meaning it cannot be changed. And since the array name is a pointer to the first element, the address of the first element 0 and the name of the array are both represented in the same memory location. So in other words, this array name points to element 0. Another way to write it is, this is identical to the address of array element 0. So in short, the name of an array represents the address where the array begins. It is also important to keep in mind that R is only a pointer to the first element and not the whole array. So let me go ahead and create an array on our code section. Let's just call this int R and let's have 5 elements. And let's print this out. And here's our array of 5 elements. I'm going to go ahead and erase this for loop. What I want to do now is print the address of each array, but I'm going to use a hexadecimal for our format specifier to print out the address. So that way it will really look like an address, not just some random integer. Actually, it's a %x, not %h. There's the address. So what I'll do is I'll go ahead and print out the address of each element array. Array 0, array 1, array 2, array 3, array 4, and their specific addresses. Now let me just print out the address of the name ARR. Notice how the ARR address on line 21 holds the same identical address of ARR element 0, just like we mentioned up here where ARR is identical or is the same as the address of ARR 0. So as you can see, the name of an array is basically a pointer, albeit a constant pointer. The thing about constant pointer, however, is that it cannot be changed. And this is where pointer variables come in. Let me also point out one other interesting thing. Let's take a look at line 21. And I'm going to get rid of this address operator, the ampersand, and I'm going to print it. And as you can see, even without the ampersand, ARR is printing the address that is identical to ARR 0. Why is that? That is because you don't have to give the ampersand when it's an array name, because the name of an array is an address that starts at the first element. And because an array name is simply an address, we can actually use a pointer variable instead of the name of an array. And pointer variables actually allow greater flexibility because it's not constant. So on line 20, I've declared an int pointer variable, star PTR. And I'm going to go ahead and set that to R. And we already know that R holds the address of array index 0. So let me print PTR. So if you notice, the PTR address is 62FF0Z, which is the same address as array index 0. So what's happening is we have an array PTR, and that is pointing also at index 0. So one advantage of a pointer variable versus an array name is it allows for greater flexibility since it is not constant. To access an array, any pointer to the first element can be used instead of the name of the array. Besides indexing, programmers can use another powerful method of moving through an array, and this is known as pointer arithmetic, which is critical in understanding pointers. And let me erase this. So here I have the pointer PTR, and this pointer is pointing at the first element of our array pointer, as indicated on line 20. With pointers, there are operations that are allowed. And one such operation is incrementing your pointer. And to better demonstrate this, I went ahead and altered the pictorial representation for the array. I added the data values inside each element, and I also added the address. And so what exactly does incrementing a pointer mean? Let's compare it to incrementing an integer. For example, if I have int I equals 0 and I increment that, and let's just say that there's a for loop here, and every time we go through our for loop, our value is incremented from 0, 1, 2, 3, 4, 5, and so on and so forth. But with PTR++, what does that mean? Do we go from 0x101 or do we go from 0x104? Well, whenever we increment, that just means that we're moving from the first element to the next element. So our incrementation depends on the data type. So in this case, my data type is an int. The size of the int pointers is, on my system, is 4 bytes. And so every time I increment an int pointer, I'm actually incrementing it 4 bytes. So from 0x100 to 104. And if I increment this again, I'm able to move to 108. And then to 112, and then to 116. So let me demonstrate this using code. So with an array, if I wanted to print out index 2, I would simply go to line 16 and print out index 2. Let me comment these out and just print out index 2. But with pointer variables, if I wanted to print out index 2, and let me draw this, if I'm starting at index 0, if I'm pointing at index 0 and I wanted to print out index 2, then I would have to add 1 and 2. So I would need to do PTR plus 2. So PTR plus 2 would actually give us the same address location as array bracket 2. And let's compile this and print it. And there it is, PTR address. And notice how the address is the same. And to print out the values, let me remove the address operator and change our format specifier to decimal. And here, let me do that. But they're not the same. So array 2 is 30, and here, this part, PTR plus 2, is 12. Why is that? That's because of order of precedence. So if I dereference PTR plus 2. With order of precedence, this is going to be evaluated first. And what is the dereference of PTR? You're going to get 10. And then this gets evaluated. And plus 2, that's going to give you 12. So in order for us to get the same value, I have to put the whole thing in parentheses. So I have to increment PTR first by 2. So that's going to do this part. So PTR will be incremented by 2, and then I have to dereference it. So let me put another parentheses here, and let me change address to value. So now when I print it, you get the same output, 30 and 30. So in short, PTR plus 2 dereference is the same thing as our array index 2. Therefore, and let me erase this, therefore PTR plus 1 dereference is going to be the same thing as array index 1, which should give us the output of 20. So let's try that. There it is, PTR value 20 and array 1 20. So we can go ahead and go on and on. So PTR, I actually don't even need this parentheses. There it is. And let me remove the parentheses because since it's only 1 and we're not adding anything to it, you should still get the same thing. So I hope you understand why these pointer arithmetic is equivalent to these array indexing. So in short, pointer arithmetic is incremented by the size of the data type. So for example, if you look at this chart and my starting address is 0x100, if I have a chart and I'm going to increment by 1 index, then our increment index 1 would be 0x101. And you often see this when we form strings. If it's a short and you increment it, then the increment to index 1 would be 0x102. N is 4 bytes, so our increment would be 0x1 0, 4. And if it's a double or a long, our increment would be 0x108. If we do PTR plus 2, then this would be 0x101, and then the second one would be 0x102. And in this case, we're going to 0x102, and then the second one would be 0x104. And in this one, our next increment would be 0x108. And in this one, our next increment would be 0x116. So in the same way that we can increment a pointer with PTR plus plus, we can also decrement a pointer with PTR minus minus. So for example, let's say that this pointer was pointing at index 4. So if I were to say PTR minus 2 and I dereference it, so we're at index 4 and I subtract 2 to it, it would be 1, 2. So this would give us the output of 30. So in terms of operations, with pointer arithmetic, we can increment with PTR plus plus. We can also decrement with PTR minus minus. We can also assign. For example, I can assign PTR plus 2 to PTR, or I can assign PTR minus 2 to PTR. And finally, in terms of assignment, I can create another pointer. So if I have an int PTR pointer, I can also declare another pointer, int PTR2, and I can assign this pointer PTR to the address of array index 4. And so now I'll have PTR2 pointing at index 4. So now with this, what I can do is I can declare a normal variable called distance, and I can assign to distance PTR2 minus PTR1. So PTR2 is at 0x116, and I'll just say 116, whereas PTR1 is at address 0x100, and I'll just say 100. And if you subtract those two, you'll get 16. But to add meaning to this, we have an int data type, and so in our int data type takes up 4 bytes, or the size of it is 4 bytes. So if you divide it by 4, you'll get 4. So therefore, the distance between PTR and PTR2 is 1, 2, 3, and 4. So what's not allowed? Well, you cannot add the two pointers. For example, you can't say PTR plus PTR2 because that will take you out of bounds of this array, and that will give you a seg fault. Likewise, you can't multiply pointers. If you multiply PTR times PTR2, again, you'll be out of bounds of your memory range, and that will give you a seg fault. You can't multiply a constant to a pointer. So you can't say 2 times PTR. These 3 doesn't even make sense because it takes you out of bounds in terms of memory location, and it leaves you to seg fault. And one last thing to hopefully simplify pointers. When you read it, go from right to left. So you can say that PTR is a pointer to an int data type. And that's all that I have for pointer arithmetic. I hope that this clarified for you how you can use pointers to traverse an array, and again, the powers of pointers. Thank you for watching.